My name is Keshwani. There's Keshwani, Keshwani. We are here because we want to prepare for the math portion of the GRE. We have been solving math problems out of this book here, the official guide to the GRE, revised journal test. If you do not own this book already, purchase one immediately. You're going to need it in order to be able to follow my work. The problem that we are about to solve is the one that you will find on page number 158, and today is our lesson number 62. Let's take a look at it. The very first problem on the top of the page about the parallelogram. We are told that OPQR is a parallelogram. We are also told that coordinates of point P are 2 and 4, and we are told that the coordinates of point Q are 8 and 6. So I'm going to reproduce the parallelogram that is given to us, and we'll go from there. The question simply is, what are the coordinates? What are the coordinates of point R? I do not know why I had the urge to put that P in the capital letter, but it's done. I'm not going to mess with it. So here is our parallelogram, as best as I can draw it. Alright, so it looks something like this. That did not come out very well, did it? It is a parallelogram. The bloody thing has to look like a parallelogram. There we go, that's close enough. It's a parallelogram. And we are told that the coordinates of point P, which is right here, point P, is 2 and 4. We are told that the coordinates of point Q, this is your O, but this is OPQ. That is the convention, that is the rule, that is the tradition in mathematics, that you, when you start naming your vertices is a plural of vertex, which is just a very fancy way of saying a corner. When you're naming your corners, you have to either go in a clockwise or anti-clockwise, or counterclockwise as Americans call it. You either go clockwise or anti-clockwise. One does not go all over the place. In other words, you cannot go OPQR, no. It has to go clockwise or anti-clockwise. OPQ, which is 8 and 6. And then this must be OPQR. This is the point we are interested in. Voila. Okay, let's get going. Enough of the talk. Okay, I'm going to put it in a different color, so it makes it easier for you to distinguish between what is given and what we are producing, what we are putting in ourselves. So we'll use the red and the blue. Hopefully you'll be able to see something. So from here to here, let's call it X. This marker is absolutely no good. The tip is gone. And when the tip of the marker is gone, it is of no use. I'm calling it X. From here to here, this distance right here, from here to here, let's call it Y. And then this distance from here to here, let's call it Z. Now, keep listening. We know, because of the fact that the x coordinate of Q is 8, therefore we know that all the way up to here, from here to here, is 8, which is what this coordinate is, 8, which means x plus y plus z, the way I drew it, equals 8. It also means that x equals 2. There is your 2, which is your x. I need the room. So even though I just put it up there, I need to raise it because that's what's given to us. So here's the solution. I prefer the black marker when I'm writing my stuff. So x equals 2, as you can see from this picture. We also know that x plus y plus z equals 8. X plus y plus z equals 8. That implies, this implies that the x coordinate of point R, x coordinate of point R, okay, point R is right here is point R, x coordinate of point R is x plus y. From here all the way up to here is 8, so it must be, from x plus y must be 8 minus z. 8 minus z. X coordinate of point R equals 8 minus z, and z is how much? Z is 2, same as this one. This is 2, x is 2, x plus y is 6, so y must be 4, and z is 2. Z is 2. Because it's a parallelogram, everything is symmetric. So 8 minus z, which is 6. So that's it, we're done with the x coordinate. Similarly, now we have to work on the y coordinate. Let's do it here. Again, I'm going to put it in a different color. This distance right here that I just plot here, let's call it A. Distance from here to here, this distance right here, let's call it B. And Q, the y coordinate of Q is 6, which is way up here. Let's call it C. See what we can do with it. So we know that the y coordinate of P is 4. Y coordinate of P is 4, which is this point right here, which means 4 must equal this distance from here to here, which is B, and this distance from here to here, which is A. So A plus B equals 4. And we know that A plus B plus C equals 6, because the y coordinate of point Q, the y coordinate is 6. Y coordinate of point Q is up to here, which is C plus B plus A. A plus B plus C equals 6. That implies the C must equal 2, which is this part right here. C must equal 2. So if you take away 2, C must equal 2. And the y coordinate of P is 4, so up to here is 4, which means B must be 2. Because you see, C is same as A. C equals A. Maybe I'm making too much fuss about it. And therefore that implies that the y coordinates of R equals 2. That's it. I don't know how low you can read. Therefore, this symbol means therefore, R is, the x coordinate was 6, the y coordinate we just found is 2. That's it, 6 and 2. The answer is E. That's it. The answer is C. That's the important part, the fact that it is a parallelogram. Because it is a parallelogram, therefore, I'm going to point out here with my hand here. Therefore, this distance here, this distance right here, is the same as this distance here, and this distance is same as this distance right here. Anyway, the rest is very simple. That was it. I don't want to stand here and keep explaining it over and over again. If you need to hear it again, you can always rewind it, obviously. I will see you tomorrow on day number 63 when we do the next problem that is given on that page. Bye now.